error and the Maclaurin and Taylor series. For a non-alternating series, how do you find the error? What's the error going to be between? Integral from n to infinity of a of n dn and greater than what? N plus 1 to infinity of a of n dn. That's how we found the non-alternating error. Does that look familiar to you? Okay. How did we find the alternating error? The error was less than the what? The next term. That's all we had for the error. Okay. Now we're going to come to Taylor series, which has Maclaurin in it. Here's what the error is less than. Are you ready for this? F nth derivative of c of x minus a to the n over n factorial. Oh, I mean n plus 1. That's the formula. Yeah, we'll get back to C. Hold it. That looks like one of these. Green or red? Notice the holiday colors. It's just like, which one? Red, because this is essentially the next term. So even though this is going to look horrible, terrible, nasty, bad, it's just the next term. It's just like the alternating. And Taylor's could have alternating series, couldn't they? That's how it's connected. So all we have to do for Taylor is just think, with the value for x, what's the next term? Not hard. Well, there's a couple hard things about it. One is we have to take the next derivative to get the next term. That's one thing. But also, Kurt noticed it right away. There's a little dilemma. And the dilemma is we want to estimate the most error possible. Okay? The most error possible is going to come from one of two extremes. C is going to be between x and a. And a was like, let's say we're estimating the natural log of 1.4. Well, x is 1.4. What's a nice number a that it's close to? 1. So C is going to be somewhere between 1 and 1.4. Now, why do you have to check both a and x? Well, which is going to be bigger, a or x? In this case, which is going to be bigger? A. So if this is decreasing, the a is going to be bigger. Which is going to be bigger, a or x now? Yeah. So if it's increasing, x is going to be bigger. So all you have to do is try a, try x, and whichever gives you the most is going to be your Lagrange error. Nasty, but we're going to just try it here. We're going to try it. So we're going to take the natural log of 1.2. We're going to take the natural log of x. What's the derivative of that again? 1 over x, x to the negative 1. The second derivative is negative x to the negative 2. Third derivative, positive 2, x to the negative 3. And negative 6, x to the negative 4. All right, and we're going to use the fourth degree to figure this out. So what is f of 1 for this one? Because we're going about x equal to 1. Or a is equal to 1, x is equal to 1.2. So f of 1, what's the natural log of 1? zip, f prime of 1. What's 1 over 1? What is negative 1 over 1 squared? Negative 1. What will this f triple prime be? Triple prime is going to be 2 over 1, or 2. Quadruple prime is going to be what? Negative 6. Yep. And let's try one more. Let's try f of 5. What will that derivative be? (24x to the negative 5th). Good. So f of 5 of 1 is just going to be what? 24. Very good. Okay. So when we're building this, we're going to build this Taylor series. A very helpful thing for you with the test coming up. We're going to build this polynomial f of x. You take f of 1 plus f prime of 1, x minus 1, plus f double prime of 1, f double prime of 1, x minus 1 squared over 2 factorial, and you just keep going. F triple prime of 1, x minus 1 cubed over 3 factorial. Are you okay with that? Keep going. So then this is going to be, in purple, a great color, f of 1 is 0, f prime of 1 is 1, so it would be 1 times x minus 1. F double prime is negative 1, so it'll be minus x minus 1 squared over 2 factorial. F triple prime of 1 is 2, so it's going to be plus 2 x minus 1 cubed over 3 factorial. By the way, what is 3 factorial divided by 2?
3.
It's just 3, so you can zap these if you want. And you'll get over 3. The next one is going to be minus what? What do you think? Look at the pattern. What do you think it's going to be? Minus, plus, minus, x to the 1 to the 4th over 4. And if we did go one more, it'd be x plus 1, plus 1, minus 1 to the 5th over 5. How are we doing? Doing okay? And so you were asked to find to the x to the 4th term. Now we go back to the problem. It says use the 4th degree Taylor series. This is the 4th degree. Power is to the 4, right? 4th degree. Once you have that 4th degree, then what you're going to do is you want to find the error. So to find the error, the Lagrange error, is going to be less than the next term, plugging in either 1.1 or 1. This keeps getting in my way here. Okay, so what term is it? Yeah, I'm going to take this 5th derivative, which is negative 6 times 1 over x to the 4th, x minus 1 to the 5th, I mean. No, I had it. 1 over x to the 4th, and this is to the 5th over 5 factorial. And you're going to put in 2 different numbers. You're going to check a equal to 1. Well, will that make any sense to put a 1 in? 1's just going to make it 0, so that's not going to help. Then you're going to put the x in 1 point, was it 2? All right, so we take the next term, use this so that we can see that the error is going to be less than negative 6 over 1.2 to the 4th times 1.2 minus 1 to the 5th over 5 factorial. You'll need a calculator for this part. It's going to be negative 6 over 1.2 to the 4th times 0.2 to the 5th over 5 factorial. What do you get for that?
24, not 6.
Hmm?
Are we doing the next term, so it'll be 24, not 6.
24.
Yeah, 6 is the wrong. Yeah. So, yeah.
Oh, 6?
Yeah, the next one is 24.
Oh, thank you. Thank you, thank you, thank you. Oh, I missed that. Good catch. I'm sorry. Yeah, I was looking at the 4th. This is the 5th one. 24.
Previous one also has it.
Yep. 24. Good eye. So good. 25 over, what was that again? X to the 5th. 24 over X to the 5th. 24 over X to the 5th. And that's going to be 24 over 1.2 to the 5th. Oh, sorry those folks at home. I want to use the next term. Don't use the one you ended up on. Use the next term. And so whatever that is, that's your Lagrange error. And just a little hint, it's hardly ever going to be A because that's going to make it 0 most of the time. But not always. So let's do 2 quick examples. 2 quick examples. From the homework, remember I told you to circle those and not to do all of them? We're going to do them right now. Estimate the range of values of x for which Maclaurin approximation sine x is accurate within 0.05. Okay? So you're going to take the Lagrange term and you're going to see what values of x will make it less than 0.005. So in this one, we went to the x, estimate the range of values which the Maclaurin approximation of this is accurate to within 0.005. What's the formula for this one? This is my answer. What will the next term be? What will the next term be? X to the 6? Yeah, it'll be 7 because they go up by 2, don't they? So you go x to the 7, yep, over 7 factorial. Now we're looking for an answer, so we're actually going to take the absolute value of that negative, so you don't need it. I'm just going to take that out. X to the 7 over 7 factorial. Nope, all you have to do is solve for x. So x to the 7th is going to be, and I think we want the terms that are going to make it greater. No, the terms are going to give it to you less. That's right. So this is going to be x to the 7th less than 0.005 times 7 factorial. And then you're going to take the 7th root of that, 0.005 times 7 factorial. And what values of x is that going to be? Less than. Is that like 0.25? 1.58?
Or 1.59.
That's fine. And so it's going to be between 1.59 and 1.59 negative, somewhere in there. Well, this is the error. We're just saying that the absolute value of this is going to be less than that.
But if there was a constant, like if there's minus something, then it wouldn't be just a negative.
Right. Nope, shouldn't. And then this one, the upper bound, you just find the next term and you put a half in for x. And all of these, what you do is you take the next term and then you put in either a or x in for c. And you'll get that Lagrange error. And sorry we should have a couple days to do this, but that's how you find that error. So like this one here, use Lagrange form to find the upper bound. If you are stopping at 3, what will the next term be for this guy? X squared over 2, x cubed over 3, what will the next term be? 4th over 4. So that's the next term. And then I think we found x was equal to 1/2 for this one. So when you do this, you're going to figure out what that value is, 1/2 to the 4th over 4. And that's going to be less than, that's going to be your approximation for your error. It's just the value you put in to get that next term.